The most recognizable silhouette in our solar system is a sphere of gas suspended inside a disk of ice. When Galileo first turned his telescope towards Saturn in 1610, he couldn't resolve its actual shape. He drew 3 separate spheres arranged in a line. For centuries, we saw the planet this way, as a stationary, finished object frozen in the deep dark of space. To see the planet clearly, we had to go there. In 1997, NASA and the European Space Agency launched Cassini. This 20-foot-tall robotic explorer traveled 1 billion miles to establish orbit and watch the system in real time. Over 13 years, Cassini recorded the mechanics of a system in motion. We watched ice boulders the size of houses smash into each other at thousands of miles an hour. We documented atmospheric tempests large enough to swallow the Earth. The peaceful giant is a trick of perspective. We are looking at a system that is constantly destroying and rebuilding itself. If humans had arrived at a different point in history, the planet would look unrecognizable. The rings are not primordial features. They formed only 100 million years ago. A moon roughly the size of Mimas, which scientists call chrysalis, wandered too close to Saturn. The planet's gravity shredded it into the debris we see today. This debris is still changing out at the edges. Tiny shepherd moons plow through the ice, physically carving clear channels and twisting the frozen material into dense, temporary knots. This schematic tracks ring rain. Saturn's magnetic field charges microscopic ice grains, pulling them into the upper atmosphere at 44,000 kilograms per second. Based on this rate of decay, the rings will completely vanish in 300 million years. The rings are a fleeting event. We simply happened to witness the cosmic moment when they were at their most majestic. While the rings decay over millions of years, the planet's surface changes on a human timescale. Every 28 Earth years, Saturn completes one orbit, experiencing a violent shift in seasons. As the northern hemisphere cools, it triggers the Great White Spot, a weather event so large it is visible from Earth through a small telescope. This cross-section shows the mechanics of the eruption. Cooling gases in the upper atmosphere become dense and sink. When this layer finally breaks, it plunges downward, forcing warm water and ammonia to shoot upward in explosive thunderstorms. These eruptions create a storm head wider than Earth. Cassini recorded these storms generating lightning 10 times a second as turbulence encircled the entire planet. Saturn periodically erases its own surface with these storms, replacing its calm exterior with new clouds. Further out, the moon Titan operates on a continuous daily cycle of active weather. In 2005, the Huygens probe descended through Titan's thick haze to land on rounded ice cobbles. It proved the moon has a physically active surface, shaped by the flow of liquid. This chart tracks how Titan mimics Earth's water cycle. Liquid methane and ethane rain from clouds, carve river channels, and fill surface seas. Beneath this crust, gravity measurements revealed a global, circulating ocean of water trapped 40 miles underground. Titan is a chemical time capsule, demonstrating how a dynamic, early Earth environment operates in the present day. The Saturnian system is a collection of active engines, decaying rings, seasonal storms, and chemical rain, all operating at once. In 2017, after 13 years of observation, Cassini made its final dive. It plunged into the atmosphere, transmitting data until the moment it disintegrated. That data documented a system in the middle of a physical transformation. We arrived during the brief window when the planet possesses its rings and the moons are still chemically active. We are witnessing a sequence of fleeting events. Through tools like Cassini, we are finally catching the universe in the act.